Hello everyone, welcome to this talk. My name is Jiazhu Yang, coming from National University of Defense Technology. Software may depend on libraries during development. When the libraries introduce breaking changes, users may suffer from compatibility issues. For example, library developers release two versions which contain backward incompatible changes like removing symbols. After that, application developers write code based on the old version, while users run the application using the new version. In this case, users may encounter compatibility failures. Also, when the two versions contain forward incompatible changes, while application developers use the new version and users use the old one, and the failure may happen again. When the breaking changes have already happened, there are different approaches to prevent the failures. First, library developers can undo the change in the latest library version, and application developers can update the application to adapt to the changes. Also, users can avoid using the incompatible library versions. There are many research works helping library developers fix breaking changes or helping application developers adapt the breaking changes. However, in these cases, users have already suffered from the failures and have to wait for new library or application versions. So a more lightweighted solution is to help users choose the right version from the very beginning without having to see the failures happen. In industrial settings, there are dependency management systems like APT or DNF for different Linux distributions. These systems can help users resolve library dependencies. For example, APT defines the library versions required by each application. These systems may still have limitations in practice. For example, DNF requires application developers to manually specify version range of all required libraries. This input might be error-prone, especially for applications that depend on a large number of libraries. Also, APT requires library developers not to break backward compatibility, but there is no mechanism to guarantee this requirement. So developers may unintentionally break backward compatibility. As a result, the version range used by the management systems may contain incompatible versions. In this paper, we see these ranges have dependency bugs. Here, we show a real-world example in glib library. The library developers change the return type of the function table insert from void to boolean. This change is forward incompatible. For example, the application home bank uses the return value, thus only works with the new version. In APT, the required version range contains the old version, which does not support the return value. In this case, we see the version range contains a dependency bug. In this paper, we designed DepOwl to detect dependency bugs and prevent compatibility failures. DepOwl takes three inputs: the library versions, the target application, and the version range required by the application. Finally, the tool reports incompatible library versions that cause dependency bugs. So users can prevent compatibility failures by not using these versions. The root causes of compatibility failures are incompatible changes in libraries. So the first step of DepOwl is to collect these changes, including both backwards incompatible changes and forward incompatible changes. We use an existing tool, API tracker, to detect the BSC and transfer FIC detection to BSC detection. Since a FIC from V1 to V2 is exactly the same to a BSC from V2 to V1. In this step, we get the glib change in our previous example. A breaking change in a library may or may not cause a dependency bug in an application. For example, the library adds a field in a struct, while the application may not use the field. So we enumerate incompatible changes in C or C++ programs and define rules for each change type to determine if the change can lead to dependency bugs in applications. In our example, the glib change may lead to a dependency bug in the application home bank, while the bug version is 2.39.1. One breaking change may affect multiple library versions, so DepOwl needs to suggest all incompatible versions. This is non-trivial, since one symbol may be affected by multiple changes. For example, zlib first removes a symbol for speed, then restores that symbol for compatibility. To address this, for each library version V, DepOwl detects if V is both backward compatible and forward compatible to the bug version. If yes, V is also regarded as a bug version. In our example, DepOwl reports the incompatible versions, which is in red color. We evaluate DepOwl by answering 3 research questions. How effective is DepOwl at preventing known and unknown failures? How does DepOwl compare with existing methods? We use real-world issues from StackOverflow to evaluate if DepOwl can prevent known failures. We first collect more than 500 issues by searching error messages like symbol lookup error. Then we manually analyze the root causes of these issues and find that 69 issues are caused by incompatible changes in libraries. Among them, 38 are C or C++ related programs, while DepOwl can suggest incompatible versions for 35 of them. We also applied DepOwl to software repository shipped with Ubuntu 19 and 10. This repository contains more than 60,000 packages, from which about 32,000 are library packages, which means they are dependent by at least one other packaging. We choose top 32 widely used library packages as targets, and DepOwl found 77 dependency bugs with regard to these libraries. So far, we only found one false positive case. We compare DepOwl with 3 baselines: the version range used in RPM packages, deb packages, and source code. For example, the application WebKit depends on the library libsoap. This figure shows the RPM packages, deb packages, and source code of WebKit, which specify the required version of libsoap. In these experiments, we also use the 38 StackOverflow issues, which are the same to RQ1. DepOwl got 35 true positives and 3 false negatives, while the best baseline got 7 true positives. This is mainly because 23 issues are caused by code snips, which are not management in RPM or deb packages. Thus, the baselines miss them. Okay, that's all. Thank you for listening.
Good morning again. we are here to formulate some questions for Zhuang Yang from the National University of Defense Technology in China. You have seen a pre-recorded video of a technical paper whose title is DepOwl, Detecting Dependencies Bug to Prevent Compatibility Failures. And I have spent a couple of minutes with Zhang in the backstage, and he told me that he is very happy to answer a huge number from the audience. So please formulate at least one question for him. If you don't have any question, I have to play once again the role of icebreaker.
Okay, thank you for the chair for.
We have a question from the audience. Guru Bandari is the owner of that question. And the question is, did you try with other cross projects and other programming language?
Okay. Actually, this in this work, we are targeting at C and C++ applications and libraries, because we found there are many existing research targeting at different languages like Java or Python, and this language actually they have a community. They have a repository to management their packages. But for C or C and C++ applications, I can't see a repository like pipe for Python, like npm or something like that. So in this paper, we just targeting C and C++, so which are not well studied by other works. As you can see, with other cross projects, I can't cannot understand correctly what's the meaning of cross projects. Actually, we test all the software in the repository of Ubuntu operating system, and we have like more than 16,000 projects. So I think it might be a huge number of projects. But the design of this paper is for C or C++, but I think it worked for other programming languages too. I don't know if I answer your question, and that's it. Thank you for your question.
Thank you, Zhuang Yang, for your in-depth answer. There is some other question from the audience? No? Okay. Are you sure? Okay, I have a question for you.
Yep.
You did a great job defining a lightweight approach to prevent compatibility failures. You validated the approach in 2 steps. Both the steps provided encouraging results on the validity of the proposed solution. For that, I understood that the applicability of DepOwl requires that the input has to be specified in a certain way. For example, the DepOwl needs default compilation directives. This affect in your experimental assessment the selection of the experimental project to be analyzed in your study, and then it might represent a threat to the validity of the results. Do you believe that the fact that the input needs to be specified in a certain way represent a stopping factor for the use of DepOwl in real development context?
Okay. Thank you for your question. If I understand correctly, you're asking the input of the tool, right? Actually, the tool DepOwl requires inputs including the history versions of libraries, and we need to actually our tool use an existing tool named ABI tracker, which try to detect the backward incompatible changes in library history. That tool requires the library be compiled with debug samples. When comparing these libraries, so we need to decide the combination directives. So in this case, our tool, the ABI tracker may suffer from false positive or false negatives if we use a different compilation directives with the problem libraries which is used in production environments. So in this case, DepOwl, we also see these false positives or false negatives. But we also can provide users with interfaces to manually input compilation directives, so that so we can avoid the false positive or false negatives we just mentioned above, mentioned before. Yes, they may actually in our evaluation section, we do see some false negative cases which are caused by the combination directives. That's all. I think I'm not sure if I'm answering your questions or.
No, you did a great job in answering my question. So related to my first question and to your answer, my second one is: are you working to let DepOwl ready to be used on a larger set of application? I mean, without compilation directives, or you need this kind of information to apply your approach? Is mandatory this information, or you can apply the approach also without that in the future, I mean?
Yes, that is a very good question. So far, we need to manually input these directives. So that input limits the practice, actually limits the usage of our tool. So now we are applying to use some existing information, like in Ubuntu system. We have the built-in scripts for each packaging in the repository. So in this case, we can use the built-in directives which are used in the production environment. In this case, we can manually, we can automatically build in all the packages with the directives which are used in production environment. So in this case, I think we can scale up to like tens of thousands of packages automatically. Yes, this is our future work, and actually I'm working on that parts in this moment.
Okay,
thank you for your question.
Thank you for your answer. You have less than 15 seconds to answer a question by the audience. Thank you, Guru. Can you think about adapting your tool to virtual environment apps to support dynamic detection of the dependency bugs, maybe in the future? 30 seconds. So your answer is very...
Okay, thank you for your question. Yeah, so for sure, I think it's yes, because our tool just require the application and the library. So if we have the we have the source code of library or application available, the tool can detect the dependency bugs between them. So I